Hello friends, in the previous video we applied the load on the slab. So we applied the floor finish load and the live load, right? So in this video we'll learn how to apply the wall load on the slab. Okay, so you can see that these walls are not exactly on the beams. So what happens is that they transfer the load to the slab, and after which the load is transferred to the beams. Okay, so we'll learn how to apply the loads due to these walls, right? Okay, so the basic principle of applying the loads is that first you have to calculate the total quantity of these walls. So after that, what you do, you multiply the total quantity to the unit weight, and if you do that, you will get the total load of these walls, right? Now that we know on slab we have to apply the load on kilonewton per meter square unit, right? So what we do, after we get the kilonewton value, we divide that by the floor area, which will get us the load on kilonewton per meter square value. That is the intensity of the load, right? So let us begin. Okay, so on the ground floor we don't have any slab, so we go to the first floor, right? So what we do, we measure all the length of this wall and calculate the quantity of the wall. For this, first we find the total length of these walls, right? So let's measure these walls. Okay, so from here up to here, because the door D1 has a wall over it, and from here up to here, right, again we take the length from here up to here. Okay, so 10 feet and 7 inches, and we take this length over here. Okay, 8 feet and 4 inches. Now we add all these values. Okay, so we open our calculator. So first we add the feet values: 11 feet plus 7 feet plus 8 feet plus 4 plus 1 inches, that is 5 inches, divided by 12. Okay, so this 4 inches plus 1, so we do it combined, right? So it enters, so 26.41 feet. If we divide it by 3.281, we'll get the answer in meters, right? So the total length is 8.05 meters. So we store this value in alphabet A. So after that, if we multiply this length with breadth and the height, we'll get the volume of these brick walls, right? So the width of these brick walls is 0.11, because it's a half brick wall, and the height, to find the height, we have to go to the section of the building. Okay, so let's measure the value. So the wall extends from top of this slab up to the base of this slab, so it's 9 feet, and we open our calculator and we divide 9 by 3.281 to convert it into meters, so it's 2.74 meters. Okay, so we multiply A into 2.74 into we do it 0.11, right? So it's 2.42 meter cube. So the total volume of these walls is 2.42 meter cube, right? So now what we do, we multiply this value with 0.7, because due to the openings we only consider 70% of the wall, right? So we get the answer as 1.698, and we multiply it with 19.2, that is the unit weight of the brick. So now we get the value as 32.61, right? So this is the load due to these walls. Okay, so 32.61 kilonewton, so load due to these walls. Okay, so now what we do, we store this value in alphabet A. So after that, we find the area of this slab. Okay, so we take the dimensions from here up to the, yeah, you can take almost center to center. Okay, so we'll take roughly, so it's 11 feet and 7 inches to, okay, so we'll go from here up to here, so 10 feet. Okay, so let's convert these values into meter square, right? So 11, so we'll use the brackets, 11 plus 7 divided by 12 times 10 divided by, so we get the value in feet square, right, after multiplying these two values. And if we divide it by 10.76, we'll get the area in meter square. Okay, so it's 10.7651 meter square, so we store the value in alphabet B. Okay, so answer is equal to, let's store this value in alphabet F somewhere far. Okay, so answer, now alpha B is equal to this, we store this value in alphabet F as well. Okay, because I think these two areas are similar of first floor and the second floor. Okay, so this area will be helpful to calculate the a load on this slab as well. Okay, so so now what we do, we divide alpha A, that is the total load, by the area. Okay, alpha B 3.02. so we divided the total load by the area to get the value of the load in kilonewton per meter square unit. So now what we do, we go to ETABS and select the slab. So it's a first floor slab, right? And we go to assign and click on cell loads and click on uniform, and after that we click on wall load and we apply the load of 3.029 kilonewton per meter cube, 3.029 kilonewton per meter square. Okay, and we click on apply and we click on OK. So after that what we do, we again open our AutoCAD file and we apply the load due to this wall on this slab. Okay, so the total length is 10 feet and 7 inches. So what we do, we convert 10 plus 7 divided by 12. Okay, so we divide it by 3.281, we multiply it with 0.11 and 2.74 to get the volume of this wall, and we multiply it with 19.2 to get the load due to this wall, and we multiply it with 0.7 to consider for the openings. Okay, and we store this value in alphabet A. Okay, so after that what we do, we divide it by the area. So alpha A, okay, so let's use this feature. So alpha A, go down, so 11 feet and 6 inches, so that is 11.5 feet. 11.5 feet times 13 feet and 10 inches, that makes 13 plus 10 divided by 12. Close this bracket and divide by 10.76 4 meter square value. So the answer is 0.8837. Okay, so if I am mistaken somewhere, please correct it by yourself, because you know using this virtual calculator is very difficult, right? So I might have done any calculation error. If you encounter that calculation error, please correct it by yourself. Okay, so now we go to ETABS and click on the slab and click on assign, click on cell loads, click on uniform, and after that we enter the value as 0.88 and we click on apply and we click on OK. Again we open our AutoCAD file and we see that on the balcony we got this wall over here, and we select this wall and measure its length. So the length is 12 feet and 8 inches. So we distribute this wall load over this entire slab. Okay, so not only this cantilever slab but this entire slab, right? Okay, so 12 feet and 8 inches. So let's measure the inside dimensions of this slab. So it's 15 feet and 7 inches in length and 12 feet and 5 inches in width, right? So it's given over here. So now what we do, we go to our calculator and we first find total load due to this wall. So 12 feet and 8 inches, so 12 plus 8 divided by 12. Okay, so we divide it by 3.281, we multiply it with 0.11 into 2.74. so this is the volume of this wall into 0.7 into 19.2. so we get the load due to this wall, right? So now what we do, we store this value in alphabet A. So we use this option and we just go down, and after that we multiply the value 15 feet and 7 inches, 15 plus 7 divided by 12 times and the value is 12 feet and 5 inches, 12 plus 5 divided by 12 divided by 10.76. okay, so we hit enter. So it's 0.8696 kilonewton per meter square value, right? So what we do, we go to ETABS and we click on this slab. Okay, so we join these two slabs, right? So we select these two slabs, click on edit cells and click on merge cells. Okay, so now we select this slab and click on assign, click on cell loads, click on uniform, and after that we apply the load of how much, 0.869. so 0.869 and we click on apply and click on OK. Alright, So now we also have the parapet wall over here, right? So parapet wall over here. So the length of the parapet wall is 12 feet and 8 inches plus. So this is also the parapet wall, right? So this will also be the parapet wall. Okay, so 2 feet and 10 inches. So total length of the parapet wall is 2 plus 12 plus 2 for this side as well, plus, so it's 8 plus so 10 inches, so 10 plus 10 for two sides divided by 12 divided by 3.281 into 0.11 into 1, right? So the value of the volume is 0.61. Okay, so let's store this value in alphabet C. Okay, where is it? Answer, store in alphabet C. Okay, so I took the thickness of this wall as 0.11. However, the thickness of this wall is 230 mm, right? So that is the almost double of this thickness. Okay, so the load is also doubled, right? So let's take 0.869 times 2. So 0.869 times 2, so that is my mistake, sorry for that, times 2 is 1.738. so we apply this load. So go to assign and click on cell loads uniform, and what we do, we replace the existing loads and we do multiply it by 2 and click on apply and click on OK. Right, after that what we do, we go for that, we go for the parapet wall. So the volume was we stored in the value of C. Okay, so we divide it by the area. Okay, so I should have stored that area, but I didn't. Okay, so we again calculate the area, and the area is so 15 feet and 7 inches. So 15 plus 7 divided by 12. Okay, okay, so one more bracket, again divided by 12 plus 5 divided by 12, again divided by 10.76, and the answer is, okay, so shift inch, it's 0. It's very less. So okay, so 0.00029 is a very less value, and you can just ignore it. Okay, so after that what we do, we go to the upper floors. Okay, and we apply the load similar to that we just did in the first floor. Okay, so now I'll fast forward the video from here. Okay, so we applied the load due to these walls, the parapet wall over here, and we already applied the parapet wall on this beam, right? Okay, so we applied the load due to all the walls, right? So this is how you transfer the load due to the walls on the slab, right? This much for this video. Hope this video was helpful. Thank you for watching and take care.